Good evening. Actually, the last sum from exercise 7.7 is for homework. I will give answer for that sum so that we are in a position to solve MCQs which are given in miscellaneous exercise 7. So, miscellaneous exercise 7, first select the correct answer from the given alternatives. These are MCQs, so presentation doesn't matter. Now, what are the factors of x raised to 4 minus 16? X square plus 4 and x square minus 4. It has factors x minus 2, x plus 2. These are the factors of denominator. This is giving 0 by 0 form. Cancel that. Now you need not write x only tends to 2 and so on. But after cancelling this factor, take the limit. To take the limit means to replace x by its limiting value, which is 2. So 4 into 8, 32 upon minus 1. So minus 32 is the answer which is given in option C. Second sum, see, it should be limit x tends to minus 2 and not x tends to 2, right? Now, x raised to 7 as it is plus 128 can be written, actually I should have written that step. Okay, I'll write here. See, this can be written as x raised to 7 minus 2 raised to 7, okay, and denominator x cube minus 2 cube. Now divide numerator and denominator by what? X minus 2. Standard limit, you should remember all standard limits. Now, what is the answer? Na raised to n minus 1. So n means 7, a means tending value, minus 2. Raised to 7 minus 1 means 6. In the denominator, 3 into minus 2 raised to 3 minus 1, that is 2. So 7 by 3 minus 2 raised to 4 is 16. So 112 upon 3 is the answer which is given in option B. B Bombay. Now third sum, find the factors in the denominator. So these are the factors. What is LCM? X minus 3, x minus 8, x plus 2. Numerator is x plus 2 plus x minus 8. Means what? 2x minus 6. Take 2 common, x minus 3. Cancel it because this is giving 0 by 0 form. Take limit means replace every x by its limiting value. So 2 upon minus 5 into 5. So correct option, that is answer is minus 2 by 25 is given in option A. Fourth one, actually, let me read the sum for you. Limit x tends to 5. Numerator is root x plus 4 minus 3 upon root 3x minus 11 minus 2. Everything is not under radical sign. It is just root of 3x minus 11 minus 2. Okay. So we have to rationalize both numerator and denominator. So numerator becomes x plus 4 minus 9 into, you have to write rationalizing factor of denominator here also, root of 3x minus 11 plus 2. In the denominator, 3x minus 11 minus 4. And what is the rationalizing factor of numerator? Root x plus 4 plus 3. Now this is x minus 5. This is 3x minus 15. Take 3 common to get this. Cancel it. Now take limit. Put x equal to 5, limiting value. Root 4 is 2. 2 plus 2 upon 3 into 9 root is 3. 3 plus 3, 6. So 2 upon 9 is the answer which is given in option D. D Delhi is the correct option. Sum number 5. Limit x tends to pi by 3 tan square x minus 3 upon sec cube x minus 8. See, what is tan square in the numerator? Sec square minus 1 minus 3 means sec square minus 4. These are the factors. Denominator is of which type? A cube minus b cube. What are the factors? A minus b, a square plus ab plus b square. Sec minus 2 gets cancelled. So we get this. Take limit. What is cos pi by 3? Half. What is sec pi by 3? 2. So 2 plus 2 upon 4 plus 4 plus 4. 1 upon 3 is the correct answer which is given in option C. Actually, MCQs on the topic limits can be solved easily using one rule given by French mathematician L'Hopital. But for that you should know derivatives. And that is why I am not using that method. Sum number 6. Divide numerator and denominator by x. So 5 sin x by x minus cos x upon 2 tan x by x minus 3x. Take limit. To take the limit means to use standard trigo limit or replace x by limiting value, which is 0. So 5 into 1 minus cos 0 is 1 upon 2 into 1 minus 0. So 2 is the final answer. Sum number 7, limit x tends to pi by 2, 3 cos x plus cos 3x upon 2x minus pi cube. Before you substitute, use formula for cos 3x, 4 cos cube x minus 3 cos x. So 3 cos x gets cancelled. What remains is 4 cos cube x upon cube of 2x minus pi. Put x equal to pi by 2 plus h, as x tends to pi by 2, h tends to 0. Now what is cos of pi by 2 plus h? Minus sin h, right? And what about denominator? 2x means pi plus 2h minus pi. Now cube of minus 1 is minus. So this is minus 4 into cube of sin h upon 8 into h cube. Now sin h upon h tends to 0. Its limiting value is 1. So it is simply minus 4 upon 8, that is minus half, which is given in option C. Sum number 8. See 15 raised to x. What is 15? 3 into 5. So it is 3 raised to x into 5 raised to x. I have omitted one step. Take 3 raised to x common to get 5 raised to x minus 1. Take minus 1 common, then take bracket common. In short, these are the factors of numerator. Divide numerator and denominator by x square. 3 raised to x minus 1 upon x into 5 raised to x minus 1 upon x upon square of sin x by x. So this is log 3 into log 5 upon 1 square. That is log 3 into log 5. So correct option is C. Remember, we are solving MCQs. That is why we are not writing limit. In college exam or in board exam, if you write like this, you will get 0. But this is MCQ, so we are interested in final answer only. So correct option is C, Calcutta, for sum number 8. Now sum number 9, we have done this type. Within bracket, take 3 common from numerator and denominator and then cancel. Now, what is a upon b raised to m? A raised to m upon b raised to m. Let me explain. Something is added to 1. Same thing tends to 0. Required index is the reciprocal of this. So what is the reciprocal of 5x by 3? 3 by 5x. This is required, not original. To get original index back, raised to 5 by 3. Same in the denominator. Minus 3 by 4x is required, not original. To get original index 1 upon x, we write raised to minus 4 by 3. This is standard limit. So e raised to 5 by 3 upon e raised to minus 4 by 3. That is e raised to 9 by 3, which is e cube. So the correct option is A, Ahmedabad. While solving MCQs, actually you can use this limit as standard limit. Limit x tends to 0, log 1 plus mx upon mx equal to 1. So here log m minus log n, log of m upon n. Within bracket, take 5 common and cancel it. So 1 plus x by 5 upon 1 minus x by 5. Log m, log of m upon n, log m minus log n. In the same step, I have divided each term by x. Now this is to be compared with log of 1 plus mx upon x. What is coefficient of x? 1 by 5. So answer is 1 by 5. Here minus 1 by 5. Denominator standard limit, its value is 1. So 2 upon 5 is the correct answer, which is given in option D. Sum number 11. You have to put x equal to pi by 2 plus h. As x tends to pi by 2, h will tend to 0. What is cos of 90 plus theta? Minus sin theta. Okay. Denominator is pi by 2 minus x. So pi by 2 minus pi by 2 minus x. Let me explain now. Index must be fully repeated. So we write minus sin h. We cannot just multiply denominator by minus sign. We have to multiply numerator also. but original denominator is minus h. We have to write it. Okay. Now, this is standard limit. Index is fully repeated. Index tends to 0. Why? Because as h tends to 0, sin h tends to sin 0, which is 0. Minus minus cancel here. Again, this is standard limit. Its value is 1. Here value is log 3. Log 3 into 1, that is log 3, which is given in option B. Now many students say, sir, why not minus log 3? No. See, the result is a raised to x, or whatever is the index, it should tend to 0. Minus sin h, yes, it is tending to 0 and is fully repeated. So value of the limit is log a, which is 3. So log 3. Correct option is B, Bombay. Sum number 12. Divide numerator and denominator by x square. Log of 1 plus 3x upon x, but 3x is there and that is why I have written 3x. And so multiply numerator by 3. We have just written that for solving MCQ, we are going to remember this result. Its value is 1. Limit x tends to 0. Log 1 plus mx upon mx is 1. So 1 into 3. In the denominator, I write 3x square, means I have multiplied denominator by 3 square. So multiply numerator also by 3 square. So 3 upon 9, that is 1 upon 3 is the answer, which is given in option D. Sum number 13, you have to divide numerator and denominator by x cube. Now see the numerator. Actually, index must be fully repeated. So sin x. But it is cube. So cube of sin x. We cannot just multiply denominator by sin cube x. So we multiply numerator also. But original denominator is x cube because we have divided by x cube. Yes, we need that. Now this is standard limit, log 3. So log 3 cube. Please do not write this as 3 log 3. No. 3 log 3 is log of 3 cube. This is not log of 3 cube. This is cube of log 3 into 1 cube. In the denominator, x cube is to be written as x into x into x. Each one gets 1x. So this is log 3. This is 1. Standard limit for solving MCQ rather. Its value is 1. Now log 3 cube upon log 3 is square of log 3, which is given in option C. 14 sum. Limit x tends to 3, 5 raised to x minus 3 minus 4 raised to x minus 3 upon sine of x minus 3. Put x equal to 3 plus h. As x tends to 3, h will tend to 0. So 5 raised to h minus 4 raised to h upon sine h. Subtract 1, add 1. So effectively this is 5 raised to h minus 1 minus in bracket 4 raised to h minus 1. Divide by h. This is standard limit log 5 minus log 4 upon sin h upon h. Again standard limit 1. I hope you won't say log 5 minus log 4 is log 1, which is 0. Log 5 minus log 4 is log of 5 by 4. So correct option is B, Bombay. Actually, they should have given that option log 1. Correct option is B, Bombay. Sum number 15. Divide numerator and denominator by x raised to 10. While writing it, we write as x raised to 7 into x cube in the numerator and in the denominator x raised to 10. Split numerator within bracket. So 2 plus 3 upon x, 1 minus 5 by x, 2 minus 5 by x. Now use this limit. So 2 plus 0, 2 raised to 7. 1 cube is 1, 2 raised to 10. So 1 upon 2 cube, that is 1 upon 8, which is given in option B. Now we discuss an important and interesting concept of left and right hand limits. See, when I make a statement like train approaches Lonavala station, one of the inferences is the direction is not mentioned. That is, whether the train is coming from Mumbai or from Pune is not mentioned. Similarly, when I say x tends to 3, okay, I do not know whether x approaches 3 from left of 3 or from right of 3. And therefore, we consider two cases. Suppose this is 3. Here you will notice that x approaches 3 from the right of 3. Limit obtained in this manner is called as right hand limit, and we write this as limit x tends to 3 plus. I repeat, we write this as limit x tends to 3 plus. Suppose the function is fx. We say this is limit x tends to 3 plus fx. You may write this as uh, x tends to okay, 1 minute. Let us discuss other also and then I'll explain that part. Now, other possibility is x approaches 3 from left of 3. Okay, the first value assigned lies to the left of 3, but approaching value is 3 only. So the limit obtained in this manner is called as left hand limit, and we write this as limit x tends to 3 minus. Remember, I am not saying minus 3. It is possible to have minus 3 minus, but here it is limit x tends to 3 minus. See, tending value is 3 only. When you take the limit and when it is required to replace value of x by its limiting value, you are not supposed to replace it by minus 3. You have to replace it by 3 only. The only thing is the value assigned or x approaches 3 from the left of 3. Now, if limit exists, it should exist uniquely. If we are getting different values of left and right hand limits, it is not allowed. So for the existence of limit, what is the criterion? The criterion is limit. I'm writing a particular case here, then we'll write general case. Limit x tends to 3 minus fx must be the same as limit x tends to 3 plus fx. Okay, and that limit is simply written as limit x tends to 3fx. Now you may ask me, sir, we have solved so many sums. In not a single sum we have used the concept of left hand and right hand limit. So how do we know that whether left and right limits are to be evaluated? I'll give an example. Suppose function is defined like this. F of x is 2x minus 1 for x less than 3. Okay, and phi x minus 10 for x greater than or equal to 3. This is called as piecewise function. Now this is the first example where we are considering piecewise function, and that is why this is the first time we are to use the concept of left hand limit and right hand limit. And we are asked to find, check if limit x tends to 3 fx exist. Okay, let me explain. Now we obtain limit x tends to 3 minus. I repeat, 3 minus does not mean minus 3. 3 minus only means x approaches 3 from the left of 3. Now use common sense. To the left of 3 we have x less than 3. So which function will you use? This one? No, this one, 2x minus 1. Now take the limit. To take the limit means to replace every x by its limiting value, which is 3 only. So 2 into 3, which is 6 minus 1. So what is the value of left hand limit? It is nothing but 5. Now we evaluate right hand limit. Limit x tends to 3 plus fx. 3 plus means first value assigned lies to the right of 3. Now to the right of 3, numbers are greater than 3. So which function is to be used? Phi x minus 10. So this is limit x tends to 3 plus phi x minus 10. Take the limit means replace every x by its limiting value, which is 3. I'm directly writing 5 into 3, 15 minus 10 equal to 5. Note that in this case, limit x tends to 3 minus fx equal to limit x tends to 3 plus fx equal to 5, and therefore limit x tends to 3fx equal to 5. Suppose first limit is 5 and second limit or left hand limit is 5 and right hand limit is other than 5, whatever may be the real number, or in some cases that limit may not exist. So in that case we have to say that as left hand limit is not the same as right hand limit, limit does not exist. But here they are equal. I will say limit x tends to 3 fx exists and its value is nothing but 5. Okay, so this is about the concept of left hand limit and right hand limit. I repeat this part again. In most of the cases it is not required to find left hand and right hand limit separately, but if piecewise function is given, then you have to find left hand and right hand limits separately. Now one function cannot have two different limits for the same limiting value. So for the existence of limit, left hand limit must be the same as right hand limit. Then and then we say that limit exists, otherwise limit does not exist. So tomorrow we'll be solving sums using this concept.